Welcome all to my YouTube channel. We will still continue in this playlist of Pytorch, and for this session, I will share with you an interesting concept we have implemented in the package of Pytorch. It's Autograd, so I will just show you, or I'll give you a small definition of this Autograd, how it is, or what it is, and how it is useful. Okay. So Autograd is an automatic divisional package in Pytorch library that helps clean and non-work to graph computing. Well, just to give you the idea about this Autograd is the gradient. This concept is very important in non-work. How that? Well, if we see with me this picture, this small picture of simple non-work, when the data is coming from some source. So we go here in the layer and go in running work after the processing and a lot of operation happened inside each layer we have here. We give for us an output. Okay, and this process it's called for word propagation. For word propagation, that means the data is coming from some source and go here to give for us some output. And we have back propagation. Back propagation is coming after we try to compare the predicted value, I mean y hat, and the original one, because these processes happen in the phase of training. So as we see here in the definition, we have training, okay? And we have the loss function here. Loss function, I mean, we try to minimize or decrease the error we have. And the back propagation is the data it's coming here to return to update all the weights we have inside of each layer here. Okay, so in Pytorch is implemented by default, and just apply it, but it's necessary to understand the mechanism of this concept of gradient, how it's happened. Well, just I want to explain that with mathematics. So to do that, so if we see with me this small example we have here of this function, have f for x equal to x squared, and differentiation or derivation here of this function f is equal to 2x. Okay, differentiation. So the same process, the same mechanism happening inside of non-work here. I will show you now an example to understand well how all these things happen. So to do that, of course, we need to import our package here. I mean Pytorch. Well, here I choose two numbers, A and B. Well, of course, it will be a tensor. So here we have A equal to tensor 5. And I will to implement or associate this category we have here. To do that, we can't just apply this attribute we have here inside of this function of tensor, and we give the true as a value for this for to associate this operation here in our tensor. So the same things happen with V here. Actually, toward the tensor 2, so I try to here the value of tensor grad equal to 2. Well, around these two variables we have here A, we see the value of 5, and also here for B, we see 2 is a tensor of course. Well, if we are taking this example here of these functions, so q equal to 3a cube minus b squared. So here, so the same example is implemented here. Okay. So the idea here, we try to differentiate here and see how we can use Autograd to make all these things more easier. Because as we know here in machine learning and data science in general, we're working with high dimensions. I mean, we need something more powerful to make this operation happen. Right? So, so with the same example here, we see the gradient. Okay, the gradient here equal to is 9a squared, and for b is equal minus 2b, because here, as we see in this equation, so the definition of this equation give us the same results here. So, and other values here, we need to remember well, a is equal to 5 and 4b is equal to 2. Okay, well, uh, here, uh, so if we replace, so after this differentiation, if we replace each variable we have here, I mean a and b, for each value we have in our test, so we get this results. Okay, differentiation of the differentiation of a here is equal to 9 squared. If we replace a by its own value, I mean 5 here, because we did here 5, okay, we have 5 here. If I place it here in this equation, I will get 325. So the same thing would be, if I replace the b with own values, it will be minus 4. But if I using back propagation, I will make all these things more easier, okay? Just what I can do here, we have equation here, as we see. I need to apply this backward here, q dot backward, if I run it. And after that, I will just uh, apply this variable here, a dot grade. After this syntax, I will get the same result here, okay? So, I mean, we can solving this kind of problems just using this grade. So the same thing would be, of course, we apply this b dot grade. I get the same result in minus 4. Okay. Here, I want just go more than that. I want just give you an example of this of a picture. Okay, pictures and matrix to show you how these things happen. Okay. So we have here weights, quarter torque to run. I chose just random variables in the range of t. I also associated this autograde here for weights. So the same thing is for B. B equal to torque to run. I chosen just one as a base because I want just taking this model is more easier just for paper education. But the same process happen in the real world of problems. Okay. We need the same steps to solve these kind of problems. Well, if we see the values we have here in these weights, because it's a random, so we see this is the results here. So the same thing for B, it will be 1 because the choosing a base is 1, okay? Well, here is one feature. I mean, this feature is like a simulation because I want to just explain that by data. So for the reason I chosen just these small examples we have here, okay? So X is a feature, okay? We are extracting a feature from our data and we see what we can happen. Well, my feature here is there is all values we have inside of this feature here, as we see. Okay, also is a random value between 1 and 10. We still continue. So here, because this model is a linear regression, well, this will be okay, is okay, output here for these things, it will be the linear regression equation, okay? I time x plus b. Here in this example, we have weights and we have x. X is a feature, weights, and we have b. Well, the parameters of our model here, it will be weights and b. Those things it should will be updated, okay? And x, it will be stay because this process is happen in the phase of training because what we want here is to find the best weights and the best b, the best weights and best bias, okay? So the best model here, it will be uh, low variance and low bias. Okay, we need to minimize or the correct error between these two parameters we have here. But for x, it will be fixed. I mean, it will be changed because it's a piece of a feature. Okay, it's just a feature. I mean, it's a training we extracting from a training dataset. Well, the loss function here in this example, it will be 1 minus output. Okay, as I explained before in the picture of non-new work, after the output, we are evaluating the error here between y and y hat. And to do that, we need a loss function, of course. So in this example, As I tell you before, for our bias, we're choosing as a value is 1, then the loss function should will be 1 minus output. The objective here is to minimizing this loss. Okay, we should find the best or the maximum error, the minimum error. Okay, we need to find the minimum error here. So the loss function here is this value is minus 0.96. Okay, and as we see here, we have autograde is activated, of course, and also for output. So we have this. Okay, so this operation, so the output is there, and also we activate the backward here for loss function, and the objective here is to update our weights. Okay, loss dot backward, we need to, after forward propagation, we need now backward propagation. We need to update the weights and bias. Okay, so for loss we activating that, and now the weight is changed. So if we compare those values and this one here, so here the value, all these values is changed after the update, after we activated the grade here. Okay, or auto grade here, gradient. Well, this is the process here. Wait, what happened? This is gradient. This is the formula of what. Uh, this is the formula of gradient. This. Okay. So, so we have learner rate here. I mean, what is the step I need to update those values? So in most of times it will be more small. Okay, there is a lot of learner rate famous Adam optimizers. We have a lot of optimizers, famous optimizers like Adam optimizer. So here, so the new updated or the new weight state should be W equal to W minus learner rate time W dot grade dot data, because I need to have a new dates or a new data here in our weight. This is the formula. Okay, so after that we have those value is updated compared to this one. Those change, all the values here has changed. Okay, so this is the objective of gradients on gradients. Okay, see the objective of gradient. I hope that's clear for you. I want just give you a big picture of all this process, how it's happened. I can work show you that more deeply with Keras also, the famous framework for deep learning. But this is the idea behind this thing, because we should know how all these things happen. Okay, before trying to make well some projects on all these things, we should first understand how happened that. Okay, so I hope that should be clear for you. Okay, maybe it's easy because idea is easy. We have a model, we have a parameters to change it, we have loss functions, we have weights, we have bias. Simple model here. Okay, and the objective of all these things is to make updates of our weights. To do that, we have all these steps to do. Okay, so happy learning for all, and I will put this file in my GitHub repository, and they will make it in my description channel. So anyone interested to have this copy and try this code or try to do something other to discover more. Thank you and see you again in the next tutorial. Bye.